Okay, good morning, everyone. One of your friends had a question about how to do data preparation, merging data sets, so on. And I found that and he has a very limited Python knowledge. So I tried to answer his question through data prep. So basically, with Tableau Data Prep Builder, you can make so many cool data preparations without even having any coding skill. So just as a case, and also your license work for Tableau Data Prep. So I'm going to show you how I answered your friend's question through Tableau Builder. So sorry, Tableau Prep Builder. So you can have a general idea how it works. In order to do some data preparation, including merging, aggregations, data cleaning, you can do something in Tableau, but Tableau Prep is much better. So just do search for Tableau Prep. And you download and basically install the software. Let me just open Tableau Prep so you can see, see what can you do. As an example, in this example, I'm going to aggregate two different tables and then use those values, the aggregated table in my Tableau, and also export as an Excel file. So this is plain Tableau Prep Builder. I click to connect to data. I'm going to bring to CSV file, and CSV files are considered as a kind of text file. I click on text file. First, I'm bringing test1. And again, I click in this connection and bring second CSV file test2. Okay, so let me just make it larger. I presumably don't need the second one. I put it here. So test1 is here. On the connections, I click on test2, and I drag the table over test1. As you see, I have two new options. I can either union or join. Union is for just aggregating together, join for finding similarities, or basically an ID column to join them. So I want to aggregate, and I put on union. So now, basically these two tables are unionized together, and the union table has all the information of these two. I can right click and just preview in Tableau desktop and do everything in Tableau. So press OK. Now my Tableau desktop will open. If I go as you see now, all of them are imported here. And now I can just keep working here with the new aggregated table that has all the information. If I want to save it into a CSV file, next to the union, there's a plus sign. I click on it. So next to union, again, there is a plus sign. I click on it and select output. At the bottom, I can find output that I want to consider, the output file, and also the location. I browse to the location that I want to save my files, I select the address, accept, and for the type, I can select hyper, which is a Tableau data extract, Microsoft Excel, and CSV file. I select CSV file. And again, if I'm not happy with the location, I can browse, go to download, select here, and run flow. So this diagram is considered as a flow in data prep. I click on run flow. And I was able to basically export my file into CSV format. This CSV format has the information of all the both two tables which are here. Let me just change the folder and so I just want to show you my answer to one of your friend's question. So how to merge two tables and use the merge data within Tableau. So as you see, I did through Tableau Prep Builder. So in case, and it was his question for his internship. So in case you need to do some data prep and you want to do it fast and without any coding, Tableau Prep Builder is the way to go. So as you see, I just drag, drop, union, merge, and just exporting everything. So it makes your life much easier. Anyway, so for today, please go to week 14 and just download everything. So today we learned a little bit of Lingo and also see another applications of LP, which stands for linear programming. So just as I mentioned over Telegram group, the assignment 13 is extended, and you can submit through Lingo, which you learned today. So it's the reason why I extended almost 1 week. And also today, you see your last assignment is basically solving one of your previous problems through Lingo. But last time, I just show you how to download and install Lingo. In case you forgot, just Google download Lingo, and you can either have Windows or Mac versions, and you just need to provide some information. And at the end here, you just need to type demo within that text box and press OK, or I think demo. Yeah, you should, sorry, you should click demo here, and then it will be available for you. Having said that, we already seen so many applications, not so many, some applications of prescriptive analytics. In almost all of them, you need to have some way of formulating your problem. I think one of your friends is not muted, so let me see who's not muted. Okay, now all of them are muted. So, you know, in almost all of them, you need to be kind of creative because you need to convert this formulation into Excel formulas. Sometimes it's a little more challenging. So today we learn Lingo. So in Lingo, you only need to make these mathematical equations and just let Lingo solve it for you. You don't need to be creative in terms of writing Excel formulas and just be able to translate everything through Excel solver. But being able to work with the Excel solver is the skills that I want you guys to learn, which you have some experiences. Let's go back to this problem. A Clark alum owns a fast food restaurant named LP Clark. He plans to start a new family meal offer containing sandwiches and hash browns. He has to make a decision that how many sandwiches and hash browns to include in the meal offer. His objective is to design a meal with minimum cost. However, there are 3 requirements of the plan. The cost of sandwich is $5, hash brown $1. The meal should contain at least 1,000 calories, at least 60 grams of protein, not contain more than 80 grams of fat, and at least 100 grams of carbohydrates. And for each sandwich and hash brown, you know amount of calories, protein, fat, and carbs. Given the information, our objective is to minimizing the cost, and the decision variables are how many sandwich and how many hash browns you want to make, which you are limited to those constraints, which the minimum like calories, protein, carbs, so on and so forth. We have learned how to formulate through mathematical equations. So minimizing 5 times S. S stands for sandwiches, H stands for hash browns. Since the cost of hash brown is 1 times H is 1, is H, so we don't put 1 there. And we have 4 constants of calories, protein, fat, and carbs. As you see, for each constraint, you have different coefficient for H and S. Again, H stands for hash brown, and S stands for sandwiches. Where do they come from? Just come from this below table. So in that table, you see for each sandwich and hash brown, how many, for example, calories, protein, fat, and carbs you might have. And we translate to these equations. And at the end, we know that doesn't make sense to have negative sandwich and hash browns. They should be positive. Questions so far, how to formulate? I think it was one of our earliest Excel solver problem, which we try to solve this problem through Excel formulas. Okay, so let's see how you can write it in Lingo from the files that you download, that either open clarkalum.lg4 or clarkalum.lng. Switch, if you click on it, this window would pop up. Or here, just click on open and browse to the file that you have. So open button is here. This yellow folder is the open button. Look at the formulation, and let me just bring the PowerPoint next to it. As you see, we're very similar. So basically, for Lingo, you don't need to learn a new program language. Just see after each line, we have semicolon. Also, even for the objective function, I just type mean equal objective function, semicolon. For each constant, there's a semicolon, and also for the non-negativity condition. But how to solve it? So this is solve button. So if you look at my mouse, it's like a dart game button. So if you click on it, you see the answer. So the objective value is 14. There is no infeasibility. So don't look at iteration. It's just something on the hood of linear programming. And I'm not sure if I can zoom in, so let me see. Maybe. Unfortunately, I don't find any zoom for you. Let me see. Yeah. So if you remember, in Excel, we didn't have surplus, but almost in all other programming languages, they differentiate a slack and surplus. So when it's less or equal, you have a slack. When the inequality is greater or equal, you have surplus. So in this plan, you should have 4 hash brown and 2 sandwiches. And the objective function value is 14. And as you see, programming with Lingo is not difficult. It's very look like how to write in the piece of paper. Just keep in mind, semicolon is needed. Also for objective function, you need to put min or max equal your objective function. So for your final exam, you're more than welcome to use Lingo. I think at least you won't be stuck because you don't, the creativity that's needed for Excel solver, if it doesn't come in your mind, at least you can just do it through Lingo. But let me wait a little bit. If you guys have questions, then otherwise I go to the next problem. Again, my goal for Excel solver was you guys to learn a new skill. So sometimes for some special cases, you need to know how to work with the Excel solver. Okay, let me just close this one. Now we do another problem, the make versus buy option. So you need to fulfill a demand, and for that demand, you have 2 options. You either buy or make 2 different types of balls, and for each decision that you make, you should it costs a different amount of money, and for sure your capacity is not enough to make everything at home. You need to purchase something, but you want to know how many from each types of ball you purchase to minimize your cost. So you have constraints, 2 policy constraints about at least how much you should produce at home, or at max how many you should purchase from outside. And also you have 2 other constraints of labor hours and budget. budget for labor. So if you remember that session, it was how we formulated. So we had a demand constraint, how much from each type of ball is needed. For example, for ball 1, M stands for make, B stands for buy. M1 plus B1, it just means how many of ball 1 you make or buy. It should be equal 3,000. So for ball 2, 3, you have some also resource constraints and some policy constraints together. And also the amount of balls you either make or buy shouldn't be negative, at least 0, which is a very intuitive condition. Similarly, go to the files that you downloaded and either open ball factory LG4 or LNG. So for Mac users, I think in the previous versions, their file is LNG, but for Windows users, I think they can open both. I don't use Mac anymore, so maybe in the Mac also it changed too. So here, instead of M1, B1, I have make ball 1, make ball 2, make ball 3, buy ball 1, buy ball 2, and buy ball 3. So 6 different decision variables of either making or buying balls. So for each decision that you make, you should have different costs. So it's the reason I have different coefficient for each of my decision variables. Going back here, those decision variables come from this table. So based on what you decide about your decision variable, you might have different cost amount. And this coefficient comes from that. This time, I have @ GIN parentheses. It just means these are integer values. So it's the way that you in Lingo, you said a variable should be integer. So it doesn't make sense if you have, let's say, 2.5 ball buying from outside, or you produce 3.3 balls. So here, GIN stands for integer value or general integer value, and just forcing Lingo to consider them as an integer value. Also, similar to before, all of these constraints, I'll just type here. So as you see, for how much, the first 3 is about your demand. The second 2 is about policies that you have from buy or make. And the last 2 is your resource constraints of labor. So how many hours, and also how much money you can pay for your labor. So the only extra thing we have is @ GIN, parentheses, and the decision variable. So if you want to have a better idea, last week I gave you a tutorial for Lingo, but most likely you don't need. So I think for you, you just need to, at most, you need to say if a value is integer or the value is greater or equal 0. I think that's more than enough. But if you want to have a better idea about how to make more advanced Lingo programs, you can just look at that tutorial, but again, it's not needed for you. And similarly, click solve button, and you get the answer. This is the objective value. You also see value of decision variable. So how many you make or buy for each different types of bulbs. Yeah. Okay, wait a little bit here in case you or your friends over Zoom has questions. Then I go to another application of linear program. Okay, today we look at another application of linear programming in real-case problem. They call multi-step transportation model. So it's very similar to a transportation model, but we have one more step, which is warehouse. So S stands for supplier. So you have some points or some origins that produce some supply. You send them over warehouses, and then will distribute after storing in your warehouses. So you have some demand locations. Having said that, you can make it a little more complex. So you might have a little bit of waste in transportation. Maybe you lose some percentage of your product to transportation, especially food waste is very common in transportation. So it either might be they have some expiration date or like they need some refrigeration and maybe sometimes it doesn't work as planned. So some kind of waste is very common in food transportation. Okay, let me open the Word document. So here we have basically 9 cities, in 4 of them, which are Orlando, Phoenix, Austin, and San Francisco. You produce oranges. You send them to a store in Springfield and Denver, and then distribute to Kansas, Omaha, and Chicago. By the way, Springfield is one of the most common city names in the United States. In many states, you see something like it, which in the capital of the state of Massachusetts is Springfield. So it's a very common city name. It doesn't mean in Massachusetts, it could be everywhere in the US. Okay, so transportation costs are given on each link. Also, in each origin and destination, you can see how much you can produce and how much is needed. Also, you can store at most 400 in each warehouse. You cannot store more than 400. Intuitively, formulation shouldn't be very difficult. First of all, you have some constraint for each origin. You cannot send more than what you produce. For warehouses, one constraint is 400. You cannot send more than 400 to each warehouse. Also, everything in, everything out. So inward flow should be equal outward flow. That's another constraint. And the last one is demand constraint. So you want to at least provide this demand. You don't want to miss these demands. I'll show you both formulations. Let's open Lingo first. By the way, instead of Orlando, Phoenix, Austin, San Francisco, I said S1, S2, S3, and S4. So it just means supplies. Warehouse, which are in Denver and Springfield, I named them as W1, W2. W stands for warehouse. And D1, D2, D3 stands for demand cities of Kansas, Omaha, and Chicago. So if you look at my objective function, I said S1W1 means from, let me just, S1W1. So it means from Orlando to Denver, because Orlando is the first supply point, S1. W1 means the first warehouse, which is Denver. So S1W1 means decision variable of sending how many products from Orlando to Denver, and the coefficient is 3 because the cost of sending one unit is 3. So the reason in the objective function, I put 3 times S1W1. It just means S1W1 means how many I sent from first supply point to the first warehouse. It costs 3 per unit. Questions about S1W1 like S2W2. So S2W2 is just from Phoenix to Springfield. So because this one is second supply to second warehouse. Also, we have W2. Let me just show you another one. So we have W1, D1. Means from first warehouse to first demand point. First warehouse, Denver, to first demand point, Kansas City. And the cost is 3 per unit. So in the formulation, you have 3 times warehouse W1, D1. So if it's difficult for you, and because I asked you to do one assignment, so instead of S1W1, it's hard to memorize. Instead of S1W1, just type like Orlando, Denver. That's good. So you don't have to put abbreviations. Yeah, it would be a little harder. Maybe you need to type more. And when you don't use abbreviation, you might misspell. So let's say instead of S1W1, if I put Orlando, Denver, And here, if I make a typo like Orlando, Denver, I start it in the wrong way. So sometimes memorizing abbreviation is harder, but at least it's easier to type, and also you don't miss a spelling. If you do miss a spelling, you get totally wrong answer. Sometimes it cannot solve it for you, but even if it can, you definitely get a wrong answer. So it's the reason instead of those city names, I'm using abbreviations, but you don't have to. So as you see, the first part is just how much I can supply or produce. So S1W1 plus S1W2 just means how many I can send from Orlando to first warehouse, which is Denver, and how much I can send from first supply point to W2, which is Denver, Springfield. So the summation of whatever goes out should be less than 240 because it's how much Orlando can produce. If I show on the picture, S1 to W1, S1 to W2. The summation should be more than 240, shouldn't be more, or should be less, both correct. Should be less or shouldn't be more than 240. And you do the same for all supply points, so you cannot send more than what you can supply or produce. So the second constraints are referring to your warehouse capacity. So whatever comes from first supplier, second supplier, third and fourth supplier shouldn't be more than 400 because it's your capacity of first warehouse. Similarly, for the second warehouse, your products come from first supply, second supply, third and fourth, shouldn't be more than 400. Sure. So for the first warehouse, whatever comes from the first supplier, second supplier, third supplier, and fourth one shouldn't be more than 400. So S1W1, S2W2, S3W1, S4W1. Summation of all should be less than 400. This is in problem. Capacity each warehouse is 400 credits. So we do constant. We consider these two equations for each warehouses. The third type of constraint is about our policy. So whatever comes into warehouse, you should be out. We cannot store everything. So although the capacity is 400, but in the next day, you should just release everything. You cannot store more than, because oranges, you don't want to store in the warehouse, you just want to release them. Maybe in those warehouses, you don't have enough refrigeration, or the quality is not great, so you don't want to store more than 1 day. So everything comes into first warehouse. As you see, S1W1, S2W1, S3W1, S4W1. Means whatever comes into W1, which is first warehouse, should be equal W1D1, W1D2, and W1D3. So whatever comes from first warehouse to the first demand point, second demand point, and third demand point. So inward should be equal outward. Same for the second warehouse. So whatever comes into the first warehouse from different supply point should be equal whatever goes out of that warehouse. Also, the last constraint is about your demand. W1D1, W2D1. So it just means whatever in Kansas City, which is your D1, it comes from first warehouse or second warehouse. and you see the capacity, or I mean the demand is 200. So whatever comes to D1 from where W1, which is first warehouse, and W2, which is the second warehouse, should be at least 200. You want to satisfy the demand. You have a minimization problem. It should be exactly 200 if you want to minimize. Sometimes it doesn't happen because you also have some distributions, and you should send something to the warehouses. So ideally, at least it should fulfill the demand. For the second demand point, either come from first or second warehouse, and also for the third demand city. So greater or equal 150. Questions? You also can keep adding constraints. So whenever if in your final exam, if I won't give any extra constraint, you don't have to. But maybe for oranges, maybe you want to put what if they are integer values? So you can put @ gene and parentheses, and you put the variable, decision variable, if you want to force them to be integer. Here, you don't have to, because I didn't provide that constraint. So for if you want to consider any policy in your, and which makes sense for you, just say, okay, I think in this problem it's better to be integer because it doesn't make sense to divide oranges in half or in third. So you can just keep adding constraints if you want, if you have flexibility for the problem. Let's click on solve. The minimum is 223.40, the minimum cost. So as you see, for example, from supply point 1, which is Orlando, to Denver, we don't send anything. You don't have to. So the amount is 0. For some of the, for example, I think the maximum is from Orlando to Denver. You send 300, and same for the others. So we solved this problem in Excel too. So again, still you have flexibility. If you want, you can solve in both Excel or Lingo. Just adopt the one that is more straightforward for you. So this is how I formulated through Excel, solved by Excel. So I made 2 tables, one for the decision variables related to the first part of transportation from supply points, S1, S2, S3, S4 to warehouse 1 and warehouse 2. And the second table is related to my decision variables from sending warehouses to 3 man points. So again, blue cells are my decision variable. It just I would decide how many I send from each supply to warehouses from above table, and in the lower table, I decide how many I send from each warehouse to each demand point. Based on these decision variables, I consider my constraints. For example, if you under supply column, if you click on 0, you see the formula is just summation of these two. So summation of these two should be less than 240, which is my supply cap. Again, for supply point 2, 3, and 4. I did this formulation because later on in solver part, I want to consider my supply constraint. Similarly, if you on row 24, there's 2 zeros on I and J column. If you see, they're just summation of whatever I sent from whatever comes to the warehouse. So S1, W1, S2, W1, S3, and S4. It just tell me whatever summation of all products or supplies come to the first warehouse. And later I compare this formula with 400. I know in var should be less or equal to 400. I cannot send more than 400. And similarly for the second warehouse. Also, in the lower table, I'm sum them up. So if you click on the first 0, it's just summation of whatever comes from warehouse to D1, D2, D3. And also whatever comes from warehouse 2, W2 to D1, D2, D3. Also, in the lower lowest row, as you see, it's 0. And if you click on it, it just show you how many products go to any demand location. Demand 1, demand 2, and demand 3. So basically, whatever you see here as my different types of constraints I have, I need to reproduce in Excel. Again, there is no step-by-step approach. You have some flexibility. Maybe you end up saying that you can replicate these conditions in Excel, but you can consider different basically configuration. That's totally fine. You need to just put that logic through Excel formulas. Questions? So if you click on solver, so as you see, my objective function is T18, total cost. It's just summation of above two cells. The first one is multiplication of, the first one is multiplication of whatever you send from its supply point to the warehouses times its cost. The second yellow cell, it just refers to multiplication of from warehouse to demand points times to their cost. You have two different costs, one from supply to warehouse and warehouse to demand points. So depends on your decision variable, these two cost cells would get different values. Also, I have two sets of decision variables, one from J20 to J23. J20 I20, which is this upper left, to lower right, which is J23. Also from I29 to K30. Besides, you see that I have all the constraints. First, I33, K33, I33 to K33 should be greater than demand. I want to provide more than demand. I24, J24. So from I24, J24, these two should be equal L29 to L30. So it just says whatever comes to the warehouses should be equal whatever goes out of warehouses. Look at the third one, I24, J24. I24, J24 should be less or equal I25, J25. So Whatever comes to warehouse, there should be less or equal 400. We cannot send more than 400. And the last constraint, K20 to K23, on the supply column, should be less than L20 to L23. So whatever you send out should be less than your supply. You cannot send more than what you can supply. Questions about the Excel formulation? The complexity that you see here is because there is no step-by-step or any regulated way of formulations. You just need to be a little creative how to replicate those mathematical equation into Excel formulas. And press solve and look at the solution. 2340 is the final answer. So in transportation plan, I mean, I made another creative way of formulating this problem. I am going to skip for now because otherwise we don't have time to cover the problem completely. In case you got questions, just let me know. But for the second part of the problem, I'm going to solve it through this formulation to just show you different ways of formulating through Excel. But let's look at the second part. Assume there's a loss of 10% oranges in each transfer. In other words, 90% of the oranges reach from source to destination every transfer. So it just means from the first transfer, which is supply to warehouse, you lose 10%. From warehouse to the demand point, you also lose another 10%. So we want to minimize the cost, fulfill the demand, and at the same time consider 10% possible loss. Again, the problem is not too difficult. Actually, whatever you send from supply to warehouse, you should just multiply it to 0.9 because you lose 10%. Whatever you send from warehouse to demand point, again, you should multiply their decision value to 0.9 because you lose another 10%. So basically, just add another coefficient of 0.9 to just consider the loss that you might have. Okay, let me open the Lingo problem. So if you look at problem, objective function is same because it just your objective function refers to the amount you send on each link. So it never cares if you lose or not. You should pay for it. So the objective function is intact. Supply constraint is intact too, because in the supply points, you haven't sent it yet, so you don't need to consider the loss coefficient. Still, in the origin, no matter whatever you send, it shouldn't be more than the capacity of each supply point. But if you look at the warehouse constraint, I said 0.9 times supply, first supply to the first warehouse, second supply to first warehouse, and third and fourth supply point to the warehouse. So here you should care about your loss because they won't reach to the warehouse. So just 0.9 or 90% of each flow would reach the warehouse. But again, the capacity is 400. No matter how many you lose, you shouldn't store more than 400. And same for the second warehouse, you might lose a portion of your cargo, but you cannot store more than 400. The most tricky part is the third part. So whatever comes in should go out. But look, in the left side, I consider 0.9, but I haven't considered the right side. Because at the warehouse, you haven't sent them yet, so you haven't faced loss. So in the left side, it just shows you the inward flow that comes from different supply points. So inward flow already faced 10% loss. But at the warehouse, you don't have any loss. Your loss is just through transportation. So as you see in the right side, I haven't multiplied by 0.9 because I haven't sent them yet. So no, again, since you cannot store anything in warehouse, whatever comes in should go out. So inward, which has 10% loss, should be equal outward, which has not faced any loss yet. Again, in this problem, your loss is through transportation. It's not at your demand warehouse or supply points. If you look at the last part, we still have here we have coefficient of 0.9 because we have loss in transportation, and whatever comes to the first demand point, either from the first warehouse or second warehouse, should face a 10% loss. So here I have coefficient of 0.9 because I know whatever goes out of the first warehouse would face 10% loss. So 0.9 times W1D1 plus 0.9 times W2D2, and we should fulfill our demand. So at least 200 oranges should arrive at the first demand point, and similar for the second and third demand points. I just wait in case you have questions. So how I formulated. So your flow was zoomed. Also, if you guys have questions, you can ask too. So again, the tricky part is how to consider your loss. So we know the loss is through transportation. So the parts that face transportation should have 0.9. And that's it, I think. But as you see, the formulation is very similar to the previous part. You just need to include some loss coefficient for the parts that face transportation. Okay, let me click solve, and this is the solution. So as you see, this time objective value increased, because basically you transport more. You have 10% loss in each transportation section. So then you have to transport more. So if you transport more, the transportation cost will be more. Yeah, I wait about 1 minute if you guys have questions. Otherwise, then I go to the Excel formulation. Okay, let's look at Excel. And I solved in 2 ways. One, just splitting 2 different tables. As you see, for the parts that face 10% loss, I add a table of 0.9, just implementing the coefficients. But I want to show you another way of formulating. So in this approach, I mean, still blue cells stands for, or just has they have the role of decision variables. And yellow cells just you do for calculations. And here I just use them for finding the cost from origin to the warehouse plus warehouse to the demand points. So on the bottom last row, you see supply and demand values. Also these two, which I mean, if you see column of Denver and Springfield, at the end I put 0. It just means the reason everything comes in should go out. For OR, PHAU, and SFO, which is sample Orlando, Phoenix, Austin, and San Francisco, I have different supply values. Above that line, I have, you see there's a 0, a line with zeros, because they have a formula. Let's just click the first one. The first one just means Orlando, which is -1, times decision variable column. It would, since just first two has a non-zero value, it will multiply to the first 2 decision variables. So the first decision variables, whatever you send from Orlando to Denver, Orlando to Springfield. Whatever you send out would sum up here, this cell. And later, I want to just say it shouldn't be more than 240. I want to relate 0, I mean, cell which calculated later, with 240, which is the capacity of my supply. Same for the second supply point, which is Phoenix, PH. So if you click on the formula, it just -1 times Phoenix to Denver, Phoenix to Springfield. Because later I want to relate this formula with 240, which is capacity of Phoenix. I want to check if I don't send anything more than 240. Same for Austin, which is column, as SF or San Francisco, which is column. So for this part of my table, I want to consider if I don't send more than my supply. If you look at next part, which is Denver and Springfield, I have -1 and 1s. -1 refers to outward flow, +1 refers to inward. So here, this formula, I mean, this +1 and -1 multiplied to the supply and demand coefficients. Again, whatever comes from Denver, Phoenix, Austin, and San Francisco have coefficient of 1 because they are inward. And for Oklahoma City, Omaha, and Chicago, the value is -1 because just outward flow. So this formula, this zero, this cell which is 0 now, because decision variables are 0, refers to how many comes in and out. The summation should be 0, and I then relate it with this 0 because I don't want to store anything in my warehouse. Everything comes in should go out. I think you got the logic for the next warehouse and also our supply points. This one refers to inward flow from different warehouses, which are in Denver and Springfield. And here we just sum the flow and then relate with the next line, which is the the demand at different destinations. So, but just keep in mind, when I want to formulate flow for supply point, which is -240, -240 again, 180, and -170, I'm sum up these blue cells. Because in each supply point, I don't have loss because I haven't sent them yet. When I want to look at the summation of inward and outward flow for each warehouses, just look at look what happened. I'm considering the loss. And similarly, for demand point, I'm also considering loss. This column here is a coefficient of 0.9 because I know whatever comes to my, let's say, Chicago, which is the last demand point, would be multiplied to 0.9 because you have a loss there. Again, I know it might be a little be very confusing because it needs some creativity how to relate those coefficients. In some cases, as I said, for supply points, I just consider the blue cells. For supply points, I consider this, again, there's a column with all zeros because they're formula. Again, this formula has blue cell times 0.9 because I know for my demand points, I also need to consider a coefficient of 0.9 because there's a loss associated to that demand point because you send from warehouse to those demand. In these two cells, I'm taking care of loss and take care of the capacity of warehouses. So from Denver to Kansas City, Omaha, Chicago, and also from Springfield. So I know that I have max capacity of 400, which I need to consider. Anyway, so again, you go solver. You consider capacity of 400, and also you set this line greater or equal 0 line, which summation of whatever go out of the supply point, whatever comes into my demand point, and also warehouses should be greater than equal next line. So for the -1, greater than equal means, for example, if -240, it will be -210, -200. For positive points, it just means 210 or like 310 or 180. It just means you provide more demand that is needed. Again, it needs a lot of creativity. It might be confusing at the beginning, but again, for your final exam, you don't have to be creative like here to find association between cells and basically formulating the answer. You are more than welcome to just use Lingo. So who is more interested to do problems through Excel solver? Who through Lingo? Some of you have at least a preference, some of them maybe. Yeah, so yeah, I also prefer Lingo, again, because you solve the problem in the minimum amount of time, and also you won't get confused in like so many how to formulate those cells. And maybe if you make a mistake in formulating, you might get the wrong answer. Going back to the Excel, so looking at my warehouse constraint, you see there's a -1 times minus 1.13 E13 or minus 5.684, whatever. So we said these two should be equal 0, or at least greater equal 0. But if you again go to solver, you see it said H20 to P20 should be more than H21 to P21. But here we got -1 something, so they're negative values. So does anyone know what does it mean? Like these minus values? How you can read this? These are actually scientific format. First one means 1.1369 times 10 raised to power of -13. I think you got the point for the next. You know how to read the second one. So these two values are almost 0. So the first one is 1.1 with like it would be 0 with 13 zeros, and then it starts from 1, 1. Second one, 5.684. Sorry, 0 with 14 zeros, and then 5, 6, 8, 4, 3. So it's very small values. So if I write the first one, maybe point. Sorry, let me write here. 0.0000005, 6, 7, 8, 9, 10, 11, then 1, 1, 3, 6. So this is almost 0. So that two rows, just read them as 0. There is a rounding error in each program language. In program languages, you have a rounding errors. So these rounding errors led to very small negative values here. If you get to programming a lot, you might see such errors comes in many calculations, which it shouldn't bother you. So you probably didn't do any mistake if you see such values. It just refers to rounding error in computers. More interestingly, if you ever work with the blockchain or cryptocurrency transactions, they check. There is so many computers around the world that they check everything comes in should go out. So whatever you send, let's say I send like let's say we are very rich people, I send you two Bitcoins. So whatever I send, you should receive. But sometimes because of this rounding error, they might see, okay, I send you 2.000001 Bitcoin and you receive maybe 1.999999. So they have some internal algorithm, they just round it up or rounding down, which they should consider. I think if you go to those concepts you see in financial transaction, you see such errors a lot, but they already have internal countermeasures just to rounding up, but we don't have countermeasures. So if I want to get rid of this, I need to put a round formula here. So round this up. Questions? Okay, if there's no question, that's for today. Next class, again, we see another application of linear programming, and that's for this semester. Your final exam has questions from linear programming and might be a little from predictive analytics, just a little. But majority would be from linear programming. You can solve them through Lingo. You don't have to do Excel. And it's very similar to previous problems you have seen. Which again, I put a sample problem from last fall. You also can look at it, and as you see, it was the major problem. I think last semester, yeah, I think 95% of their final problem, final exam was this problem. 5% the remaining, 5 or 10% other parts, which I think everybody got the point. The complete credit. Okay, since yesterday was, what was yesterday? Yeah, so today we don't have any attendance, so that's okay. Okay, thank you very much and take care. Yes.